Okay, now we're going to look at functions, the sine and the cosine functions. We haven't actually seen them as graphical functions yet, and we'll do that through an investigation. So I'll do the first one and you can try the others. It says use technology to graph on the same set of axes, sine x 2 sine x, sine x half sine x, sine x minus sine x. So notice the number in front of the sine is changing. So here it's 1, here it's 2, and it's 1 again and a half, 1 again and minus 1. And we can plot all of these all at the same time. So to do that, we bring up our graphics calculator and we're going to put in first of all sine x, which is there. And then as the y2 function we'll put in 2 sine x, and as our y3 function we'll put in a half sine x, and the last one is minus sine x. It's like a minus 1, it's really minus 1 sine x. Okay, now to graph this we can press zoom fit. It tries to do the best scaling, but we know that this is going to be in radians. It's got it listed at the top there, and that's what it tells us here to do. It says to use calculator, make sure the mode is set in radians and your viewing window is appropriate. Now, appropriate viewing window would be so that we can see a complete cycle, and that would be a revolution from 0 to 2 pi is a complete cycle. So what we could do is set up the window range, and we're going to go from 0 up to 2 pi. Okay, now we know that the values of sine can't be bigger than +1 or minus 1. They can't be outside those regions. So we can set this at 1 and minus 1. Okay, now if we press graph, that's the first one, sine x. Here's the next one, 2 sine x. Now that's going past our 1 minus 1 limit, so we're going to have to go back and expand that window. This is a half sine x. Clearly it's bringing it down half the amplitude, and here comes minus sine x. Now, just so we can see the red one, we can go back to the window and change the y min and y max so that we can see it in view. So we'll go -2 to 2 and then press graph. Now the question says record the maximum and minimum values, state the period and the amplitude. Okay, now the period is the time for it to complete one cycle. Now you can see with all of these, they all have the same period because a complete cycle is 2 pi. After 2 pi, it starts repeating itself. Now this just keeps going on and on. You could easily see that if you extended the window out, the x max out to a higher number, this will just keep going on and on like a wave. So the period's the same for all of them. If you look at the amplitude, you can see if I press the trace key, it'll tell us which function we're on. Now if I press the left button, we're going up and down along the sine curve. Now if we want to know what the maximum value is, we can just go second calc and go to maximum, and it just says go to the left of the place that you want to test for the maximum. Just go to the left of it, press enter, then head to the right of it, press enter, and it says, is this a good guess in this region? We press enter, and it gives us the exact answer that it is 1. Now we're expecting that because we know that the y coordinate, or the y value of sine x, is 1. Likewise, we could do the same and get -1 over here at the base of that blue curve. So that's y equals sine x. Its amplitude is 1. Amplitude is defined as the distance from the rest position, that's this axis, to the top, the crest of that wave. If you imagine the blue line as being a wave, then the x-axis is called the rest position, and the amplitude is the distance, the maximum displacement or distance from the rest position. In this case it's 1. Now that's sine x. If I press the down key, it will jump onto the red. That's 2 sine x. Now it's easy to see that that is an amplitude of 2. It's sitting up the top there. If I press the right cursor key in the trace, you can see that it will just go up and down that red line, and the amplitude of that red line is 2. So it's kind of hinting that whatever number's out the front is the amplitude. Let's just check with the others. Jump onto a minus sine x, and we can see that the amplitude of that one is -1 as well. All it is inverted, so that there is the maximum amplitude. We actually say the amplitude is 1 because we don't take into account direction. It's just the maximum displacement from the rest position. So sine x and minus sine x both have an amplitude of 1. It's just that they're inverted. And the last one is the black one, which is the half sine x, and we can see that the maximum value there is 1/2. The amplitude is 1/2 for that one. So we can come back and answer all of these questions here. So it says, for each of those graph record the maximum minimum values, state the period and amplitude. If you're using a calculator, use the built-in functions to find the maximum minimum values, and we've done that. So the question, how does A affect the function in y equals a sine x? So the A is the amplitude, is the number sitting in front of the sine. That will tell you what the amplitude is. So if we're to state the amplitude of these three here, the amplitude will be 3, this one will be √7, and this one will be 2. The minus just means it's inverted, but it's still got an amplitude of 2. Okay, so that finds what the A does. Now you try investigation 2 to see what B does. They change the numbers, but it's in between the sine and the x. And then there's another investigation later on, which you can also try, which is here. This is where they've got an x takes c and an x plus d. So you can try that one there. Just pause the video, come back for the solutions. Now in investigation 2, we're looking at the b value, that's the number just in front of the x. So we could do sine 1x, sine 2x and sine 3x. So here's sine x, I'm going to put in sine of 2x and sine of 3x. Now that's different from the previous one where we had the 2 out the front of the sine. This time it's behind the sine in the bracket, tied up with the x value. So if we have a look at what this looks like, here is the sine curve. This is 2 pi for the what we call the period. The period is the distance for one cycle. Now the red one has a lot shorter period and the black one has an even shorter period. So if you look at the red one, you can see the red one, its period finishes right here. because we've got it going up, down, and then finish. That's one cycle, just one wave. And that actually is half of what the blue one is. Now the blue one, which was sine x, the period of that one we said was 2 pi for a full cycle. Now the sine 2x is half of that, so it's going to be pi. And we can see even on the divisions here, it goes 1, 2, 3, that's 3.14, that's pi. If we look at sine 3x, you could probably guess that you just grab your 2 pi and now it's going to be a third, so it's divided by 3. So this one was 2 pi divided 2, this one's 2 pi divided by 3. And you can see that with the black one, it's a lot quicker, so the period of this one is sitting right there. That's a third of the full 2 pi section. So looking at the summary back in the book, we can see here that in general we can say that the period is 2 pi over b. So summarising the last two things we found, we have that A, when it's out the front, that affects the amplitude, and the amplitude is the positive version. It's those lines there are the modulus, or the positive version. So if it's minus 3, then the amplitude's 3. Y equals sine bx, whatever that number there is, then the period is 2 pi divided by that number. Alright, so if you did these questions here, the period of this one is 2 pi divided by 3. This is 2 pi divided by a third, which will actually be the same as timesing 3, so that'll be 6 pi. This is 2 pi divided by 1.2, and this is in general form is 2 pi divided by b. Okay, so as that number gets bigger, the period gets smaller. And as this number gets bigger, the A value gets bigger, the amplitude gets bigger. Okay, so that does investigation 1 and 2. Now we're going to look at investigation 3. And that's looking at x take C and x, we could say that take D. It's when C is inside the bracket or when it's outside the bracket. So I'll just use 2 as example. So I'll do x take 2 when it's inside the bracket and x take 2 when it's outside the bracket. So back to the graphics. I'll delete that last section. I'll just add in here, we want to have x take 2 minus 2 close bracket, and then this one down here we want to have x, but this time the take 2 is outside the bracket. Now when we graph this, we'll see first of all the sine curve, the basic sine curve going 2 pi period, and here comes the one with the 2 inside the bracket, and here comes the 2 outside the bracket. Now the way to read that is that the red one, it's been the sine curve has been kicked to the right, moved to the right by 2 units. So the crest of the blue has become to the right by 2 points to become red. This has gone across 2, and this has gone across 2, so it just moves it to the right. So if you've got sine x take 2, then compared to the sine x graph, that's the sine x, what the sine x take 2 graph, if you move this across by 2 units, you'll get this function. Notice the opposite nature of it. We're moving it plus 2 to the right, even though there's a minus 2 there, it's the opposite. The bottom one, that was the sine x take 2 outside the bracket. Now with respect to the base curve, when you put in the -2 outside the bracket, that's equivalent to moving the whole sine curve down by 2 units. So it's a -2. Notice the sign -2, -2, they'll be exactly the same. If that was +2, this is +2. So you can see with the blue one, it's been moved down by 2 units. That's gone down 2, that's gone down 2. Now it's pretty obvious because this is the y value and the y value is being moved to subtract. You subtract 2 from the y value. Whereas up here, it's wrapped up with the x value. That's what's moving it left and right. This one moves it up and down when it's at the end. So we'll see the textbook notes. And this is their summary. So we can say that in general, x takes c is a horizontal translation. That means movement, moving it horizontally, c units. X plus d is a vertical translation that moves it up and down through d units. Notice this has a minus in it, that has a plus in it, and this is plus plus. Now combining it together, we could move it up and we can move it up and down and left and right together if we have both in there. So putting a minus c would move it across the right by c, and a plus d would move it up by d. We write it like this. This is vector notation. This means you move something across c and move it up d. And we'll cover vectors later in the course, but you write it like that, across c and up d in square brackets, doing 2 translations in the one hit. Right, so if you had tried some of those questions in the investigation, you would see that for this one here, state the max and minimum values and period. The key thing is looking at this one here. This is moving it to the right by 2, that's moving it to the left by 2, and that moves it to the right by pi and 3. If we look at this one here, that moves it up by 3, that moves it down by 2, and they want you to come up with the general rule which we just looked at. Okay, we can now summarize all of this together by looking at the one big general sine function, and this is it here. So in general, we can have a number out the front, a number in front of the x, number in a bracket, and a number sitting outside at the end. The number at the front affects the amplitude, the number in front here affects the period, and the period is given by 2 pi on b. And the c affects the horizontal translation, that's whether it goes left or right, and d affects the vertical translation, whether it goes up or down. That's called the general sine function, and we can see now with a few examples how that works. So a typical question would be as in 4C2. We'll just do some of those. So the very first one is y equals sine x take 2. So one part A, first of all you always draw the base sine curve and then you change it according to the new function. So the base sine curve always starts at 0, it goes up, down and up, and we know that that's a full cycle, which is 2 pi. And to do sine x take 2, we just put in some measurements. That goes from 1 down to -1. So if we're going to do sine x take 2, we drop everything down by 2. So this 1 would come down to here. This -1, if you drop it down by 2, would come down to -3. And this 0 would come down to -2. So we could see we'd get a graph looking like this, where everything drops down by 2 units. So that is the y equals sine x graph, and this is the y equals sine x take 2 graph. Okay, so you can try, just pause the video and try the rest of those using the rule we've learnt. And here are the answers. So sine x take 2, that's been dropped down by 2. Sine x take 2 has been moved to the right by 2. X plus 2, that's been moved to the left by 2. This plus 2, that's been moved up by 2. This one, x plus pi and 4, that's moved to the left by pi and 4. This one here has been moved across by pi and 6 and up by 1.